Hello everyone. My name is Vivek. I am a software developer. I make videos about Kubernetes, containers, Go as a programming language, and software engineering in general. So in this particular video, we are going to look into Helm. What exactly is Helm, and why do we use Helm when we talk about installing applications on Kubernetes? So very basic definition of Helm is it is a package management tool for Kubernetes, or package manager for Kubernetes, right? So now if we talk about what exactly is package manager, so let's say you have written an application, right? Any kind of application, either your application is going to be running on Kubernetes without talking to API server, or the application is Kubernetes native application that is going to talk to Kubernetes API server to do some things. So any kind of application that is going to be deployed on Kubernetes, let's say you have written an application, right? Now let's assume that you want to distribute that application so that others can also use that application or deploy that application on their Kubernetes cluster. So in some of the previous videos, we have actually written an application, right? Library application in Go, and we have also written all the manifests that are required to deploy that application. Right now, if we are not using, let's discuss how would we distribute our application if we are not using any package management tool. Okay, so let's say these are all the these are all the these are all the manifests that are supposed to be deployed, right, in order to get this application up and running. Okay, so if we are not using any package management tool, what we will have to do is we will have to upload all these YAML files to a specific location, let's say, right? And from that location, anyone who wants to deploy this particular application would download all these YAMLs, or all these resource manifests, and then he is going to apply all these manifests either one by one or all at once, right? So this would be one way to distribute your application if we are not using any package management tool, right? So again, either they will have to download every manifest file, or what we can do is to make things easier, we can club every resource manifest into single .yaml file, and then we can try to upload that, and then others who want to download or others who want to deploy this application into their Kubernetes cluster are going to download this, and then they are going to actually apply this manifest into their Kubernetes cluster. Right now, let's discuss about what exactly is the problem with this particular approach. Right, so for example, first of all, how are they going to figure out where your application is deployed, right? So there are chances that if I'm maintaining a repo for my project, I would be mentioning the details about where all these manifests are, right? But if we are using package manager, in that case, using package manager, we can also search for the applications, right? So for example, if we talk about package manager in case of Debian based Linux systems, so if we talk about apt, right? So in case of apt, we can use apt to search for the available packages, right? And then we can download them into our machine. Similarly, let's say in case of Red Hat based systems, we can use any other package manager, for example, either RPM or micro DNF, to search for the packages, and then we can download them, right? So if we are just uploading our manifests without using any package manager, people would not actually be able to search for our application, right? The other problem that I can think of is, how are we going to distribute, let's say, another version of our application? So let's say we have this application uploaded and we want to publish another version, right? How are they going to deploy the another version? Are they supposed to download all the files, and then are they supposed to manually kubectl apply all the files. So things like that, these are some of the problems that we are going to face if we don't use any package manager to distribute our application, right? And this is where Helm helps us to distribute our application. So for example, if I have written this particular application, right, what I'm going to do is I'm going to create a package, right, out of these manifests, and then that package is going to be distributed using Helm, right, so that anyone else can just download and install the package using Helm, right? So now I think it should make some sense. Helm is a package manager, like I discussed, apt for Debian based systems and RPM for Red Hat based machines, right? Now, again, let's say I am using Helm. We should discuss, before diving into much more details, we should discuss about some things. So for example, let's say this is the application that I want to distribute using Helm, right? So there are some terminologies that we should be aware of. So for example, one very common thing that we use is chart. What is Helm chart, right? So let's say I am packaging an application, right, or a package, let's say, and in that case that group of manifests or that package, that application can be called as a chart, right? So for example, let's say library is an application that we have written, and for library application we have, let's say, grouped together these many manifests that are supposed to be deployed using Helm, right? So this is going to be called as a chart, right? So this would be a chart for the library application, right? Or in other words, we can say that library chart, right, or library application. So we can say that chart is synonymous with application, right? So for example, if we talk about again, Linux based, Debian based Linux system, let's say you have to install Go, right, using apt, right? So Go would be an application. Similarly, in the case of Helm, this library application that we are packaging using Helm, that application is going to be called as chart, right? Now, a chart should be stored somewhere. So for example, if we talk about manifests, I said that manifests are supposed to be uploaded somewhere, so that if someone wants to deploy your application, he would be able to, or they would be able to download the manifests and then apply those manifests, right? Similarly, once you have created chart for your application, that chart should be uploaded somewhere, right? And that location is called repository, Helm repository, right? So for example, let's say I have created a Helm chart for library application. Now I can create a repository as well, right, to host this particular chart, right? Now I introduced another word, right? So we can say that host is just a fancy term for a location where your application is uploaded, right? So for example, let's say I uploaded my Helm chart to a specific location. We can also say that I have hosted my Helm chart, right, so that others can download that particular Helm chart. So that location is going to be called as Helm repository, right? Another term that we should discuss is what is Helm release, right? So for example, let's say we know what is Helm chart, what is Helm repository. Now if we talk about Helm release, let's say I know that library application is hosted on a repository, let's say stable repository, right? Stable is the name of the repository. Now what to install this application, what I would do is, let's say I would just ask Helm, or run a Helm command, Helm install MySQL from stable, right? Now there are chances that I would like to install another instance of library application in the same cluster, right? So you see what I'm trying to say here, right? If we are trying to install multiple instances of same chart or same applications, those instances are going to be called as releases, right? So for example, we can install same application with release name, let's say library 1, right? And we can install another instance of same application with the name release2, right? And these two instances are going to be called as Helm releases, right? So yeah, these were some of the basic things uh, before we dive into why do we exactly use Helm, right? Now let's say we have created we are going to look into how exactly a Helm chart looks like, but let's just assume that a Helm chart consists of all these manifests as of now. So let's say I have created a Helm chart out of all these manifests, right? And we want to host, or we want to upload this chart to a repo somewhere, right? So that anyone else can download the application and then install that application. Now this application would actually be available using Helm search functionality as well, right? So using that dependency management tool, people can actually search for this particular application and then they can just fetch and install it in their cluster, right? Now that we have set up a basic understanding of what exactly Helm is, let me just go ahead and try to show you how does a Helm repo, or how does Helm chart looks like. Sorry, how does a Helm chart look like? So if we run, don't worry about this command as of now, right? I am going to discuss about these things in more detail, maybe in next video. So Helm create library is, this particular command is just going to create a very, what should I say, dummy chart, right, with this particular name, right? And this particular chart is going to have some dummy manifests. So now if I just show you how the directory structure looks like, so all the manifests that we discussed about. So for example, if we talk about our library application, by the way, if you don't know what this library application is, in some of the previous videos I have actually wrote this application from scratch and deployed it on top of Kubernetes. So maybe you would like to check that out. This is on my GitHub as well. So let's say I want to create Helm chart for all these manifests, right? Because eventually all these manifests are supposed to be deployed on top of Kubernetes to get my library application up and running, right? So all those all those manifests are going to be inside the templates folder for the chart that we have created, right? So we can see that some resource manifests here, and again all these manifests are dummy as of now, right? So this is going to have some dummy information and we can have a look into that, but let me just go through the structure here. Now the other file that we are seeing here is values.yaml, charts, and notes.txt, right? So now notes.txt is a file, right? Or notes.txt contains the text that is going to be shown if someone installs your application, right? So for example, if you have created a library application, right, if someone installs your library application, content of the notes is going to be displayed in their standard output, right? Test is for tests. And if we talk about chart.yaml is going to have the details about, obviously, your chart, which particular version of chart you are releasing, what is the name of your application, and things like that. Moving further to charts directory here. So your library application can be dependent on some other applications, right? So for example, let's say I am using Prometheus, right? Just for an instance, I'm using Prometheus to store some matrices about my application. So when I install library application, Prometheus should also be installed, right? So this, in that case, Prometheus is called as subchart, right? And details about subcharts is going to be inside this particular repository, right? So again, if we talk about subcharts, let's say my library application depends on another application, right? Let's say Prometheus. So in that case, if I install library, or if someone installs library, Prometheus application should also be installed along with library application, right? So those, in that case, Prometheus is called as subchart, and details about subcharts are stored in charts directory. Now, if we talk about this values.yaml file, this is very important, and this is the main file, I would say, in any Helm chart, right? So let's say, yeah, I mean, this is about the structure of a Helm chart. Now, if we talk about what is the significance of this values.yaml, so before diving into that, let's discuss why do we exactly use Helm, right? Helm templates, or Helm to manage, or to package our application, right? So if we talk about our library application, right? In this particular case, let's say I want to, if in the case if I have not actually packaged it using Helm, if someone installs these particular YAML files in their cluster, if they want to update something, so for example, if I show you the content of PVC, right? Here we are using storage class as do block storage, right? But what if in their cluster they don't have this particular storage class, right? So in that case they will have to update this manifest, right? So this is an instance where manual intervention is required, right? Because let's say PVC needs a storage class, right? And if we have specified the storage class and that storage class is not actually present in the cluster, in that particular case they will have to update this YAML file manually, right? Similarly, there are a lot of other things where there are chances that your application might require some manual intervention. So for example, let's say your application by default runs on port 8080, right? But in customers or in someone's machine, that port is already in use, right? So they would like to specify another port to run your application, to run the library application, right? So in that case they will have to edit the manifests of, let's say, services or ingresses, right? So all these manual intervention can be removed if we use Helm to package our application, right? And we are going to actually look into how we can achieve that, right? So as we discussed, let's say our deployment.yaml here depends on some values, right? That is supposed to be provided by someone who is installing the application. All those details can be specified in values.yaml, right? So in values.yaml, I can say that I am expecting storage class name, right? And then from deployment.yaml or from pvc.yaml, I can get that particular field that is specified in values.yaml, right? And that value for that particular field can be specified while installing the Helm chart. So let me just go ahead and try to open this in text editor, and then we are going to have a deeper look into about these files, right? So yeah, if we talk about values.yaml here, right? So don't worry about all of the other things. Let's say we want to get storage class name, right? And by default, let's say I want to specify the storage class name to be standard, right? So in this particular case, if I try to install this chart now, right, I can specify the value for storage class name dot name to whichever value I want to, right? So for example, I have storage class with name gp2. What I can say is Helm install this particular application while setting storage class dot name to gp2, right? And in templates dot deployment dot yaml, I'm going to say, for let's say I have another, just for example, let's say I have another file here, or let me copy the one that I have in library application. So cp copy that to here, not here, in templates, right? So pvc.yaml. Now in pvc.yaml, what I'm going to say is get this value from dot values dot storage class name dot name, right? And this is how we can make our manifests dynamic, right? We can specify runtime values and we can have a lot of other things, right? So this makes sense, right? I mean, why do we actually want to package our application using Helm? So that we get a lot of functionalities, but this is just an instance. You can specify some variables, some fields, or you can set custom values while actually installing the chart that is provided, right? So this is one thing. And another thing that we can have a look into is let's say we can specify a whole lot of other things in values.yaml, right? So for example, let's say your application spins up three pods, right? And those three pods are, let's say, pods, and names are 1, right, 2 and 3, right? So in that case, what I can do is I can just in deployment.yaml, I can iterate over these values, right? I am not going to look into the syntax as of now, but we can do that. I mean, what are all the things that we can do using Helm? We can discuss about them. So in deployment.yaml, let's say I can iterate over these values, and then for each of those values I can create anything that we want to. For example, we can create a deployment manifest for each of these values. And again, while installing, someone wants to name it to something else, they can obviously do that, right? Using, let's say, Helm install chart name, and they can specify the values for the fields that are specified in the values.yaml, right? And there are a lot of other things that we can also do. I'm looking into the notes that we have to discuss about. So for example, again, let's say in values.yaml, I have specified something, right? And in the actual manifest, I want to use those values. So to use those values, obviously we can either use them as they are in the values.yaml, for example, storage class.name, or we can use some standard template functions to modify those values. So for example, let's say I have to let's say convert it into uppercase, or I have to quote it. What I can do is I can just use a templating function like this. So right, so quote here is a templating function, right? So now value of storage class name here is going to be standard, but in uppercase, not in uppercase, but it is going to be quoted, right? So there are a lot of predefined standard functions, right? For example, quote, uppercase. I mean, there are a lot of functions that come out of the box with Helm, right? And obviously you can write your own template functions as well. We call them named template functions. So for example, if we have a look into helpers.tpl here, so we can say that these are named templates. So for example, library.fullname, right? This function can be used in any of the manifests that we want to, or we can just go ahead and try to write our own template, right? And then that template function can be used in either of the manifests. So for example, let's say I want to write a function, right? And that function is going to get me details about the image that I'm going to use, right? So for example, let's say by default the image that I'm going to install is library :1.0, right? And if :1.0 is not specified, we want to use latest, let's say hypothetically, right? So we have a control flow logic here, right? If tag is not specified, then use image as library colon latest, or use library colon whatever the tag is specified, right? So all these things can be enclosed into a named template function, and that template function can be used from any of the manifests that we have in the templates, right? So yeah, I mean, I would like to emphasize again into this particular thing. So for example, let's say you have a logic, right? For example, while installing my application, if user is not specifying the image tag, right, in that case latest tag should be used, right? Or if they are specifying the image tag, in that case that image tag should be used. So this is a logic, right? And that logic can be enclosed into a named template function, right? And that template function then can be used from any of the manifests, for example deployment.yaml, or pvc.yaml, or service.yaml, anything that we any manifest that we have inside templates, right? So we can read values from a lot of places. For example, when I say we can read values, I mean we can read values inside resource manifests from a lot of places. For example, we can read values from values.yaml, or we can read values from release, or we can read values from templates, and we can also read files in some cases, right? So yeah, I mean, this was pretty much it. What I wanted to discuss about, right, in this particular video. In the next video, what I'm going to do is I'm actually going to make a Helm chart, right, for the application that we have here, right? So the library application that we wrote, I'm actually going to create Helm chart for this particular application, and then we are going to actually install this application using that Helm chart, right? So yeah, this was pretty much it. To summarize the things, Helm is a package manager tool for Kubernetes that we can use to install any application, or we can search for application on the available repositories, right? So if I show you the repos, these are all the repos that are available in my installation as of now. If I want to search something, right, Helm is going to search for that application in all of these repos, right? If you have created chart for your application, and your chart is hosted somewhere else in some other repo, we will have to add that repo so that that particular application would be discoverable, right? So yeah, this was pretty much it. If you think this was helpful to you, maybe consider liking this video. You should share it with people and subscribe to the channel. Thank you so much.